Bienvenidos a Vox Terra. Does it feel to you like we are entering an era of flooding? Does it feel to you like floods could hit anytime, anywhere? If it does, that's true. And does it feel to you like the media is largely not explaining the climate change mechanisms behind these extreme weather events? If it does, I attribute that largely to the power and the influence of the fossil fuel petrochemical industries. So to break it down for you and simplify it for you, today I want to share with you an excellent article from Scientific American titled "Vapor Storms Are Threatening People and Property" by Jennifer Francis, November 2021 issue, where she says in her abstract, more moisture in a warming atmosphere is fueling intense hurricanes and flooding rains. Well, how does this here work, these flooding rains and intensified hurricanes? Well, here's how. Water vapor. Water vapor is the gaseous form of H2O, or the gaseous form of water, of liquid water. Now, unlike most other gases, atmospheric gases that is, water vapor is not evenly spread throughout the globe. Water vapor is more abundant in steamy tropical areas, as we imagine, and then extends northward and southward towards the poles through atmospheric rivers. Now, in the past, these rivers really help stabilize our climate and evenly distribute what she calls energy throughout the atmosphere. But now, due to this heating planet, these atmospheric rivers are intensifying. So factor one in this increase in vapor is the warming oceans. As the oceans warm, the oceans and other water bodies warm, they simply give up more vapor. More evaporates into the atmosphere from those warmer water bodies. The warmer atmosphere can now retain and hold more of that vapor before it condenses into cloud droplets that can create flooding rains. And this extra vapor provides moisture and energy for storms. Storms of all kinds, and she lists summertime thunderstorms, nor'easters, and hurricanes, as well as snowstorms. But not just more moisture, the extra energy makes them more likely to intensify. And indeed, here's a good statistic for us. The amount of vapor in the atmosphere has increased about 4% globally just since the mid-1990s. Extreme precipitation here defined as an extreme storm that delivers more precipitation in one event than 90% of a year's storms do. And she cites the EPA citing NOAA that indeed, extreme rains and snows are happening more frequently and will increasingly become the norm. Again, citing NOAA, in the USA, 9 of the 10 most extreme years for one-day precipitation events have occurred since 1996. And that's troubling, this mid-90s, 1996 business, because that is when I first began to notice the climate was changing. I first began to notice it firsthand, and I first really began to notice how the media seemed to be ignoring it. Statistic: since the late 1980s, about 1/3 of U.S. property damage caused by flooding, $73 billion worth, has been attributed to increases in heavy precipitation. Here she cites Hurricane Harvey, 2017 event, dumping in some Houston neighborhoods 5 feet of rain in 5 days, and rain bands that delivered 6 inches of precipitation an hour. Now, at the outset of her article, she started off by citing the storms of 2021, the summer of 2021, the extreme flooding in Germany and Belgium. China, where commuters posted videos in the subway of flooding of an underground subway and people gasping for air at the last remaining air pockets in that flooded subway. Okay, so look, if you're like me, it's probably pretty intuitive by now. The hotter atmosphere is holding on to more moisture. The hotter oceans and water are giving up more of the hotter atmosphere. Why? It's pulling more moisture out of everything, the soil, all of it. I get that. So then it's going to come down and rain harder. I get that. But what about this whole business of more energy? A little less intuitive. So there's something called latent heat. Latent heat defined as energy absorbed or released when a substance changes form. Think of it as shape-shifting. For example, from water to vapor. Sometimes I slip into my accents, keep it lively. Well, heat in the climate system causes water to evaporate into the air. That evaporation, that vapor now carries with it latent energy. Now, if that there vapor then condenses into clouds, droplets, or even dew on your lawn, that heat in that process of condensation from vapor back to liquid releases heat into the atmosphere. And why that release of heat, she says, creates a bubble of warm air, which will be lighter than the surrounding air and will rise. Now, because the upper layers of the atmosphere tend to be cooler, the bubble can continue to rise and grow, all the while condensing additional water vapor into clouds and releasing yet more latent heat. Why, to really create a picture of it, she gives the example of if you've ever flown in an airplane through one of those cauliflower-like shaped clouds, and you hit super turbulence created by a rising column of air. So latent heat combined with increased moisture is the main fuel powering these intensified hurricanes and thunderstorms. And it also fuels rapid intensification. Rapid intensification. Well, now what does rapid intensification mean and how is that defined? Rapid storm intensification defined as maximum wind speed increases by 35 miles per hour in a mere 24-hour period of the storm. Or it's defined by the storm's central atmospheric pressure dropping at least 42 millibars within a 24-hour period. So again, that air pressure just means the amount of pressure the atmosphere is exerting on the Earth. So I'm assuming here that as that pressure drops, that column of air then rises and fuels the storm, as she described with the airplane example. And statistic for you to remember, rapid intensification is now more likely. In the past 40 years, the probability that a storm will intensify has increased by 5 times. That's a lot. Imagine you made 5 times on your money. Well, now the probability that a storm's intensity is going to increase has gone up 5 times in the past 40 years. And the oceans play a big factor because the oceans have absorbed 90% of the increased heat caused by the addition of greenhouse gases from the excessive burning of fossil fuels. And that increased heat she describes as a battery that the storms can tap into to charge their strength. Now, she also mentions a couple of miscellaneous factors that need further study regarding the atmosphere and storm intensity and extreme precipitation events. Like she mentions the decreasing of wind shear. Well, what's wind shear? Well, wind shear apparently is the difference in speed or direction between winds closer to the ground and those high in the atmosphere. And that decrease in wind shear means those lower atmospheric winds are less likely to tear apart that heat column. Now, speaking of heat, her article also gets into heat and how water vapor is increasing heat, especially nighttime heat, and all the consequences forthcoming, like increased heat-related deaths, especially among the elderly and infants, as well as all life forms who are adapted to one climate being forced to migrate now to another climate, and the changes in disease vectors that brings with it. Finally, she discusses the feedback loops that this increased water vapor is creating because water vapor itself is also a greenhouse or a heat-trapping gas, like the carbon we have added to the atmosphere and like the methane. Now, she highlights some technological fixes in order to make storm prediction more reliable. But I would like to more focus on her recommendation that we rein in the amount of greenhouse gases being added to our atmosphere by the excessive burning of fossil fuels, methane and carbon dioxide, as well as not clear-cutting forests, which absorb the carbon dioxide. But here, I would like to focus on the political problem and the media problem. We need to highlight to people the fact there is a powerful fossil fuel petrochemical funded denial industry that has slowed down information getting to the public and making its way into the media. Also, politicians are funded by those interests. That is what we largely saw why the main Democratic holdout, Joe Manchin, wanted to remove climate provisions from the infrastructure reconciliation package. I believe that's the reason, as do many others, that politics, Joe Manchin's fortune in the coal industry. Well, hey, I hope you found this video really helpful, and if you did, please make sure you are subscribed to my channel. You have clicked that notification bell, you are liking, you are commenting, and until next time, as always, peace be with you.